Label the following graphs having used either even, odd, or no symmetry. And I know I didn't read that word for word. I'm changing it kind of just the way it makes more sense. Here's what we need to do. We need to determine if each of these have even, odd, or no symmetry whatsoever. So this one, as you notice, it's reflecting over the y-axis. Whenever something reflects over the y-axis, that means it has even symmetry. So it's a even function is a better way of saying it. It has symmetry over the y-axis or with respect to the y-axis, but it's an even function. It's a better way of saying this. This one, notice that it looks like it's reflecting over the origin, which would be odd, but since it's not directly over, and notice that if you choose any good point, like here, I almost have a good point at 2, -4. If you had the point 2, -4, let me put this down here, I'm sorry, 2, -4. If it's odd, then you would, if you switch both of these to negatives, or you switch the signs, -2, +4, it needs to be a point. If I go to -2 and +4, it needs to be a point, which someone could look at that and say, well, that looks pretty good. But the kicker is in here. You can see that this is not exact, that in here, the points don't line up. Let me try it again. Let me show you. If I would have chose, let's say this is 1, okay, -1, I'm sorry, -1, and we'll just roughly round and say that's -1, 1. Well, what that means is if it's an odd function, then the point 1, -1 also needs to exist. So if I go over to 1, notice here it's about 1, 0. So that's out. So this is no symmetry. It's neither even nor odd. If you go to this one, now this one is odd. It's a perfect reflection across the origin. It is an odd function. You could choose any good point here. We'll say that 4, 6 is a good point there. That means if 4, 6 is a good point, and if it's odd, then the point -4, -6 should also exist. Let's check it. -4, -6, that does exist. Notice that they're reflecting through the origin. The origin, the O's kind of go together. Origin and odd. Odd has to go through the origin. It's another reason this is not. So this is a odd function. Finally, let's check out the last one. So an even function, again, reflects on the y-axis. This does not reflect on the y-axis. You don't have it going this way. Nor is it reflecting over the origin. So this would be no symmetry, or you could say also neither even nor odd. So this is no symmetry. And so now, just in conclusion, just the algebra, if you will, behind this system is that if it's a even function, the x values should be opposite of one another. The y values won't change. Like, for example, this was +2, 0. This is -2, 0. So anything that's even will reflect just the x. The x values will change, but the y's will stay the same. If you found another good point down in here, or any of these, if we said this is 3, -4 here, if we just said 3, -4, then that means -3, -4 should also be a point. That's what's true with even functions, is just the x value switches signs. But with odds, you have both the x and the y values switching signs.